Alright, let's do an example here for the quotient rule. So determine the x values on the function f of x equals 2x squared over x plus 4 where the tangent is horizontal. Okay, so first off, if the tangent is horizontal, what's the slope of it going to be? What's the slope of a horizontal line? Well, the slope of a horizontal line is just 0. And we know that the derivative of a function gets us the slope of the tangent at an x value. So we want to find out, when does the slope of the tangent equal 0? So that's what we're going to be solving. So if our function is 2x squared over x plus 4, the derivative of it, because it's a rational function here, we can just use the quotient rule. And what's the quotient rule again? So the derivative of it, we would take the derivative of the numerator first. So the derivative of the numerator is 4x times the denominator as itself, x plus 4, minus the numerator as itself, 2x squared, and then the derivative of the denominator. So the derivative of x is just 1 and the derivative of 4 is just 0. All over the denominator squared. That's our quotient rule that we went over in the previous video. So what do we want to do here? We want to simplify the numerator. So let's distribute this 4x in the brackets. So 4x times x is 4x squared. 4x times 4 is 16x. Negative 2x squared. This 1 plus 0, that just becomes 1, right? So 1 times 2x squared, negative 2x squared rather, is negative 2x squared. And this is all over x plus 4 squared. Let me continue this here. So this 4x squared minus 2x squared, these are like terms here, right? So 4x squared minus 2x squared, that's just 2x squared. And then this 16x we write plus 16x as itself over x plus 4 squared. And we want to keep simplifying the numerator, right? So we could see if we could cancel anything out with the denominator. So what can we factor out? We could take out a 2x from these two expressions and we'll be left with x plus 8 over x plus 4 squared. So in this case, nothing in the numerator cancels out with the x plus 4 squared in the denominator, but simplifying it makes it easier to answer our question. So basically, we want to know, when is this expression going to equal 0? Right? So when will this equal 0? We want to know the x values for which it will equal 0. Well, if the numerator is 0, then 0 divided by anything will just be 0. Notice how I said the numerator has to be 0, not the denominator, because anything divided by 0, if the denominator is 0, that would be undefined. But 0 divided by something is just equal to 0. So basically, this 2x, x plus 8, has to equal 0. Right? And notice how it's already factored for you. So x is equal to 0, or x can be, in this bracket, negative 8. Right? So if x is either 0 or negative 8, the numerator will be 0, and then 0 divided by any number will be 0. So the x values for which the tangent is horizontal is either at x equals 0 or at x equals negative 8 for this function. Alright, so let's do a quick recap. So we were looking for when the slope of the tangent is horizontal, or when the slope of the tangent, the derivative, is equal to 0. So what we did is we first found the derivative of this function here using the quotient rule, simplified it, and then once you get to this point, you pretty much want to see when is the numerator going to equal 0. And there's two cases. Either when x is 0, because this whole 2x will be 0 then, or when x is negative 8, because then this bracket will be 0, and multiplying the whole thing will make it 0. So those are your two x values where the slope of the tangent is horizontal.